Welcome to the Solid Print 3D webinar. Today we're going to be going through, what is the best 3D printer, but more importantly, what's the best 3D printer for you. So I'm joined here by my colleague Tom. So Tom's going to be talking over some of the more technical bits and answering your questions as well. So the agenda that we're going to cover is what 3D printers are on the market currently. Does it matter if this is my first 3D printer, and what's some of the things to be looking out for when you're looking to take your first steps into additive? One of the things that you'll be asking yourself when evaluating 3D printers is how important is the surface finish, and if that's a critical factor for you, then we'll be covering some options there. And what sort of mechanical properties are going to be required, and what sort of loading conditions, and what sort of 3D printers are most suitable for those which are most demanding. And we're also going to have a look at some large format 3D printers and talk about some 3D printing strategies for dealing with larger parts. And then we're going to cover, how is 3D printing helping in this current climate that we're all finding ourselves in. And then we're going to have some time for some questions at the end. So here's a total minefield out there. If you've been looking at 3D printers at all, then you probably would have experienced this firsthand. There are many 3D printers out there that offer very high specs, but there are certain risks with those. So if you look to the left there, you've got the print volume going up towards the top of the screen and the price going up towards the right of the screen. So some of those printers that maybe have a larger print volume but are lower on price, you'll probably notice quite a few of those if you can see the very small images. Apologies for the size of the images, there's just so many to fit on the screen. They're all open, so you might end up with cold air rushing onto printing on those, and failed prints on those. So that's one thing to be watching out for right off the bat there. So we've done our research basically. So when we set up Solid Print 3D years ago, the director Neil spent a good amount of time going through all the different options available on the market and finding the best in class solutions. So these are some of the most popular solutions that we offer, which tackle different applications. So one of the things that you're going to be asking yourself, does it matter if this is your first 3D printer even? So all 3D printers are very easy to use compared to existing manufacturing processes like CNC machining or lathing. Especially with CNC machining, you need to be putting tool paths on parts before you can actually manufacture them, whereas with a 3D printer, if you've got that 3D file, you can throw it at the software that comes with the 3D printer, change a couple of settings, and then you're good to go 3D printing that part. But like any other manufacturing process out there, there's a lot to learn with additive manufacture, and that's also where we come in, and we'll assist you guys in optimizing your parts for additive. So with everybody that we sold 3D printers to, we've seen big gains in reducing individual part costs. A huge one is reducing lead times, which allows for higher project throughput. If a project's taking half the time to complete, then you're going to be able to be doing twice as many projects that year, and also reducing the amount of human resource required and being able to reallocate that to more important tasks. So does a 3D printer need to be reliable for you? If that is the case, then I'll definitely be looking at a solution that's above £1,000. Some of the cheaper solutions are around £100, £200, and you'll be experiencing far more failed prints on those, and what we call like an 80-20 relationship, where 80% of the time you're faffing about with the printer and 20% of the time it's actually doing what you'd like it to do. So another thing to watch out for is the software as well. Make sure that this 3D printer comes with its own slicing software, and have a good look into that too. So there are a lot of different applications out there, and a lot of different solutions. So understanding what the 3D printer that you're going to be purchasing can be used for is very important. One of the big misconceptions commonly spread about by the media is that you can, throw anything at a 3D printer and it does it, no problem. But there are 3D printers designed for certain tasks, and we're going to be covering, what sort of 3D printer is best for doing what sort of part in the next few slides. So another way in which we can help you guys, as I touched on earlier, is helping you guys design for additive manufacture. So I've just popped in a couple of examples here of how we may be going about that. Say if you want to be fixing parts together, something that people aren't commonly aware of is that you can actually pause prints, which is what's happening to that image on the right there. So that's been paused whilst it's been printing, and somebody's dropped a steel nut into that print, and then you're going to be able to print over the top of that. So you're going to have a steel thread embedded inside a 3D print. So that thread is not going to shear off like a 3D printed thread might do, and you're going to be able to achieve a really strong mechanical fixing on that sort of part. And then to the left, you've got a threaded insert, which is being inserted with the solder gun. So it's been heated and melted into the plastic. So there are lots of little tips and tricks like that, which we know about here, and we're able to provide expert advice to you guys going forward. As we provide a real well thought out service, much like Solid Solutions with SolidWorks. If you've ever used their support line, it's the same service carried through and to Solid Print 3D.
So another thing to consider when you're looking at 3D printers is how important your surface finish is to your parts. Now, if you're just looking to create space models, just prototypes to get an idea of what your part looks like in your hands, then maybe surface finish is less critical to you. If you're wanting to show a client and you want it to be almost injection molded finish, then that can really help kind of point you in the right direction as what 3D printer is going to be the most suitable for you. So if we have a look at the image here, you can see this has been printed with the same printer, but using a different setting. And one of the biggest settings for when you're trying to improve surface finish is looking at your layer height. So on the left-hand side of the image, that's been printed with 50 micron layer heights, and on the right-hand side, 320 micron. Now you can see there's a lot more stair stepping with the image on the right-hand side, and with the smaller layer height, we've got a much better surface finish. Now the biggest thing with this is kind of weighing up quality versus time taken to print. So if you're trying to print the same model with a lower layer height, you're going to get a much better surface finish. And if that's really important with the part you're printing, then obviously you want to go with a lower layer height. But if you're wanting to just get a quick prototype out, want to be able to print quicker, but less bothered about the surface finish, then printing with a larger layer height is going to be what you're after. Now, if surface finish is absolutely critical, what you'll want to look at is an SLA 3D printing solution. So we use a lot of acronyms in 3D printing. So SLA printers, they're stereolithography prints, and what they use is they use a resin, and that resin is cured layer on layer and produces very high detailed, good surface finish and intricate models. So if we just have a look at the process. So what you have is you have a vat of resin, and with the SLA printers that we have here, we use the Formlabs printers. You have a wide range of materials, so you can have your standard colored resins, but you can also have your engineering strength resins. So you've got durable, you've got high temp, you've got tough, and you have your vat of resin, and a laser using mirrors are able to direct where the laser's got to be pointed, and it cures and hardens that resin layer upon layer to build up your part. Now, with this particular type of printing, you actually need to use a slightly different way of orientating your parts. So to get the best finish, you actually need to print at 45 degrees, which, contrary to most FDM prints where you want to print directly and try and remove the amount of support required, SLA is a slightly different process to get your head around. And you can see in the image there, the part being removed away from the support materials. So those structures on the build plate are actually just the supports. So obviously the biggest benefit of SLA printing is, one, the surface finish is great. You can have a huge range of materials as well, particularly with the Formlabs printers. As I say, you can mimic, if you're mimicking polypropylene or HDPE for injection molded prototypes, you can actually have living hinges. You can have high temp materials, so if you need to go up to 270 degrees. And you can also have a range of various colors if you're looking to do high detailed models. Another really interesting thing with SLA printing is your parts are more isotropic. Unlike typical FDM prints, where parts can delaminate because they're built up in layers, you can actually have more isotropic strength throughout the parts, because you can actually get down to 25 micron layer heights. And you can also print very high detail, very small and intricate parts as well with SLA printing.
Thanks, Tom. So a good case study where SLA 3D printing is being used currently to battle the coronavirus is in producing nasal swabs. So you can see to the left here on the image on the left, there's a whole nest of nasal swabs that have been 3D printed out of that vat of resin that Tom was just talking about. So one of the reasons why SLA 3D printing works really well for the nasal swabs in particular is the sort of geometry that we've got there. So we've got long vertical struts, especially with lower end FDM machines in like the hundreds, or sometimes in top end of 800, 900 pounds. Those sort of machines will struggle to produce a long strut very straight as they get further away from the home position on that sort of FDM machine. The parts start to distort, whereas SLA deals with a long strut far better, and also producing those struts as solid geometry rather than like you might on an FDM printer with hollow infill. That sort of geometry works far better on the SLA machine, as well as being able to make use of the biocompatible materials on the Formlabs machines. So the Formlabs Form 3B is actually the machine which is aimed at the dental industry, which has access to all of the Formlabs dental resins, which are all biocompatible. So it's a great machine for producing nasal swabs to help the NHS out. It's being used currently.
So another type of 3D printing process is SLS printing. Again, another acronym. This is selective laser sintering. Now, the way this process works is you have a bed of powder, typically nylon, and the whole bed is actually heated up to just below melt temperature, and then again is selectively melted at these specific points to actually then form the parts that you're after. Now, one of the massive advantages to SLS printing is actually it doesn't require support materials. So there's no faff with actually removing supports, and the reason for that is the powder actually acts as the supports. It's actually self-supporting. And another great advantage to that as well is you're actually able to stack parts as well. So you can actually fit as many parts as possible into the bed, and they don't require supports, and they don't also have to be the same part as well. So you can actually print a wide variety of different parts all within that bed at once, making it great for batch production. So if you're wanting to kind of print 20, 30 parts at a time, again, they don't have to be the same parts at all. But these are great for maximising the build volume. And as I say, you're saving a lot of that time from removing supports, support structures, which is a thing with 3D printing.
So one of the ways in which SLS is being used currently to help battle the coronavirus again is 3D printing these valves for breathing apparatus. So these parts could be printed on an FDM or SLA machine, but one of the things that you're going to run into is you're going to find it difficult to remove some of the support material and some of that intricate overhanging geometry going into the inside of the part that you can just see on the top of those valves there. Whereas, as Tom mentioned, the SLS process, the powder actually acts as the support, so it's all self-supporting geometry. So the post-processing on these parts is far easier using the SLS process, being able to blow all the excess particulate out of the internal geometry of the part there, rather than having to manually snap off the supports. Also, there's a huge amount of these parts required, so they're able to nest a lot of those onto the machine, one above the other, and really achieve good production throughput of those parts. So another question that you might be asking yourself is what sort of mechanical properties is going to be required on your part, and what sort of materials are you going to need access to? So the Ultimaker 3D printers that we do is an FDM machine, and they have a huge amount of materials available to them. As they're open source, you can buy filaments from many different places online or from different resellers, and you'll be able to load those materials into the Ultimaker and run whatever material that might be. So you can run anything from flexible material to fairly hardy parts like nylon type parts, and biocompatible parts as well. So there's a huge amount of materials available on the Ultimakers. The Form Labs, again, they have a huge amount of materials available to them. In the way that that differs to the Ultimaker, Form Labs 3D printers are always running their own materials, so you won't be buying third-party materials off the internet and running those in the Form Labs. You'll be getting those from Form Labs themselves. The SLA process is a little bit more intricate, so you know, if you're using the wrong sort of resin with the wrong sort of SLA printer, you're more likely to run into issues there. So those with a little bit more of a limited material choice, the Cindo is a really good 3D printer to get started with. Prints very reliably and to good quality, and incorporates a lot of features that helps you achieve that reliability, like an enclosed print volume. But because it's a lower end version, the nozzle doesn't heat to the higher temperatures required to 3D print materials like nylons. So you'll be printing PLA and ABS on there. So the Markforged 3D printers, the limited material choice is incorporated into the design of Markforged essentially. So Markforged 3D printers produce very accurate parts very reliably, and they produce them to a very high strength. So the composite 3D printed parts are actually stronger than aluminium. And the way that they achieve this is by controlling the materials that are going into the 3D printer, and also making sure that the hardware and software all works together. So it's an enclosed solution which ensures that repeatability and reliability. So I'm going to pass you on to Tom, who's going to run you over FDM 3D printing.
So FDM 3D printing is probably the most common type of 3D printing. So if you've come across 3D printing before, it's more than likely going to be an FDM 3D printer. So how does FDM 3D printing work? And before we go on, I'll just again explain the acronyms. So it can be referred to as FDM or FFF. Now, FDM stands for Fused Deposition Modeling, and is actually a patented name. So it's also referred to as FFF, which is Fused Filament Fabrication. Essentially, they're both exactly the same thing. All it means is you extrude a material, a filament material, out of a hot nozzle, and you build your part layer upon layer. You can think of it as though you're using a glue gun to build up your part in the X and Y, and then you gradually build that part up in the Z, moving up to build that part up. So what's the advantages of FDM printers? Well, they're the most common type of printer, so there is a huge variety out there. They're very easy to use, and there is a huge range because of how many there is out there. You can have things like auto bed leveling. Some of them open source, some are not. What do we mean by open source? Is you can use a wide range of filaments that don't have to specifically be for that manufacturer. So that gives you the ability to actually print. If you've got an open source FDM printer, you can actually print with hundreds of different types of materials, giving you a huge versatile option to print with.
So how FDM 3D printing is being used in the current climate. Anybody that's making face shields will almost definitely be using the FDM 3D printers because those face shield components are, they're not very large, but to fit them on, say, like an SLA 3D printer, you might be hard pressed to find a cheap SLA 3D printer that can print something of that size. And also, just because of the wide adoption of FDM technology, there's a huge amount of people using it out there. So we were able to get in contact with a lot of our customer base and get them to help us out through 3D printing these face shields for the NHS, of which we were getting just over 600 out a day over the last couple of weeks. And another little example of how little FDM 3D prints can help stop the spread of coronavirus. So one of the ways of utilizing FDM is by using something called fiber reinforcement, which is available on the Markforged machines and is a process that's been patented by them. And it's the one which I touched on earlier, which allows you to produce parts that are stronger than aluminium out of composite materials. So you can see the image to the right there, where you're 3D printing in either a nylon or a nylon reinforced with fiberglass or with Kevlar, with carbon fiber. So I will touch on why you might choose those different reinforcement options in the next couple of slides and the mechanical properties of each. So the best way to explain Markforged fiber reinforcement is to think about a concrete structure with rebar going through it. So the concrete alone won't stand up to nearly as much force as, say, when it's reinforced with rebar. So that rebar is going to add a huge amount of strength to that structure and help out with vibration that might be going through that structure, just adding additional strength as well. And Markforged 3D printing works in a very similar way. Instead of using concrete, though, it's using plastic, nylon-based plastic. And instead of using the rebar, it's using continuous fiber strands to really increase the strength of those parts. So to run through the process, you would start off with your 3D file. You would drop that into your slicer that comes with the 3D printer. And then you would select areas that you want to inlay continuous fiber. Depending on exactly where you need that strength and rigidity, you can select where you want to put that fiber reinforcement. The Markforged printer will then swap between two nozzles. The first nozzle will be inlaying that fiber, and then the second nozzle will be covering that fiber with plastic material. And the finished part to the right looks exactly like that. You don't see any of the fiber reinforcement on the finished part. It's all embedded inside there. So if you're focused on this graph to the top left, down the bottom of that graph, we have the nylon material, which is a common 3D printing material along with ABS. Just above that, you have the pale blue curve, which is onyx material, and that's the base plastic material used on the Markforged machine. And that material alone is almost twice as strong as an ABS, and that is a nylon with chopped carbon fiber particle within it, which is that black plastic material. So above the onyx material, you'll see the Kevlar material, which is that yellow curve. So a part reinforced with Kevlar will have a more gradual stress strain curve. So if you were to suddenly break it, it wouldn't fracture. It would actually bend a lot more before breaking, which can be a really important factor in designs where maybe you're putting something inside an aeroplane, and when it breaks, you don't want particulate going all over the cabin. And also reducing vibration going through a part. Kevlar is a really good option. Then you've got the high strength, high temperature fiberglass above that. And then right at the top there, you've got the carbon fiber reinforced part, which provides the best strength to weight ratio. So if you're looking to produce parts that are stronger than aluminium, but much lighter than aluminium as well, then you can start 3D printing those parts on a Markforged machine, and then also start to gain benefits and reduce lead time, reduce part costs. So just to run over the Markforged 3D printing platform and how it ensures that repeatability and reliability and accuracy with each 3D print. Each part of the Markforged platform is designed and controlled by Markforged, so the materials, the software, and the hardware. So one of the things that we will touch on in one of our future webinars in a little bit more detail is how the Markforged machines actually have laser inspection scanners, so you can create inspection reports of parts as they're printing as well, which really helps ensure that parts are meeting tolerance. So one of the ways in which fibre reinforced 3D printing on a Markforged is being used currently to help battle the coronavirus is somebody's looking at making a press tool for forming an aluminium bit of sheet for a face shield. So the images to the right are just kind of examples, but they're actually going to be looking at making a press tool to bend that aluminium sheet. And here we have an example of a press tool in action that's actually bending 4mm sheet steel. So you can see it going down there. It's going to press some slots into that sheet steel. So with Markforged 3D printing, you can really start to look at producing bits of tooling for the workshop alongside jigs and fixtures and end of arm tooling. All of these things where 3D printing previously, the parts may not have been accurate or strong enough. That's where Markforged is stepping in and really increasing the capabilities of any production line and allowing faster changeover of production lines as well. So if you were looking to print larger parts, the industrial solution that we offer for large format 3D printing is the Big Rep 3D printers. So they range from printers that print a build volume of about 1 meter cubed up to which is actually 1.5 meters in the X. So if you are looking to produce parts all as one component and not be joining parts together, maybe to do one-to-one scale prototypes or to be functionally testing parts that are all kind of like one body instead of different bodies joined together, then the Big Reps are a really good solution for that. There's also higher strength materials on the Big Rep machines, so you can get a carbon fibre particulate injected into a PET material that you can use on the Big Rep Studio G2. So you're able to make large, very strong parts on the Big Rep machines. And they also print very quickly using something called MXT technology, which is their patented technology, which we'll go into more detail about that in a future webinar. So if you're looking to not really print parts up to about 1 meter cubed, but you're looking for a slightly larger build volume over what's commonly available, then we do have machines that have a larger build volume but aren't quite as expensive as, say, as a Big Rep machine. So I'm going to play a quick video which is going to show how Big Rep large format 3D printing is being used to reduce lead times in the architectural industry. So that's just an interesting application of how large format 3D printing can be leveraged to reduce lead times and costs of something that would be machined out of MDF previously, and you wouldn't be able to bring that mold to site and do what they were doing there with that Big Rep mold.
So we're just taking a look there at the large format printers, the Big Rep large format printers. Now, it may be the case that 90% of the time you actually need to print with a smaller build volume. And there's the odd few occasions where maybe your parts are too large for the build volume. So that's not to say you can't print them at all. There's just a few things you can do to get around them. Now, the first thing you can do is, if your part's not fitting into your 3D printer's build volume, we can simply just split the part, whether that's in half, into four, using your CAD software, and then it can actually fit inside your build volume. Now, you can actually glue your parts together. So we use Loctite 401. Slightly more viscous, so sometimes when you're trying to actually bond your parts together, the surfaces might not be perfectly flat. They may have a few layer lines. So actually having a slightly thicker glue is actually better for bonding your parts together. Another couple of alternatives which we did briefly have a look at before is the ability to put in metal inserts, threaded inserts, and also captive nuts as well. So you can actually design your parts to be made into, split into multiple parts to actually fit within your printer. Okay, so just a recap really on the benefits of FDM. They're very quick and easy to use. They are the more affordable printers, so they start at a lower price point. And you can also, if you're looking for high strength end use parts, then Markforged actually use FDM, and then they also embed those continuous fibers to create the high strength parts. Again, looking at the various ranges between them, you can get fully enclosed options, which helps prove your reliability and consistency with the parts as well. So just a bit of a recap. So we've looked at FDM printing, SLA printing, and SLS printing. So FDM printers are very versatile printers, wide range of materials. SLA, if you're looking for great surface finish, and again, good range of materials with the SLA ones as well. And then SLS prints, you're going to get a slightly grainier finish. The layer lines will be less obvious, but won't be quite as smooth as SLA, and that allows you to actually not have support material, so you're able to actually print kind of batch production parts. Now that's great if you're looking to actually produce multiple and fill the bed, but actually it may not be the best solution if you're just looking to do one-off parts. If you just got one part inside a massive powder bed, then actually there's going to be waste material there. So actually that's good if you're looking to run a lot of batch production.
So production 3D printing is really where a lot of gains in efficiency are being made in industry currently. So I spoke briefly about when we provide anybody with a 3D printer, we commonly find that there are huge savings in lead times, individual part cost. They're able to reallocate human resource, do more projects in the business to reduce, to increase profitability essentially. So prototyping has been very proved out with 3D printing, and production 3D printing is something that has now become possible with Markforged 3D printing, as you're able to produce parts to tolerance and produce them so they're stronger than aluminium, and do it all in-house, really helping optimize your process. So the way things are changing with 3D printing is that you're going to be cutting out a lot of existing stages in the supply chain. So where you might need to be buying billets of material from elsewhere, and they'll need to be cut somewhere else, stored in a warehouse somewhere else, and then shipped to you, stored in your warehouse, and then you're going to have to be cutting subtractively from that material, then potentially dealing with the waste material. So there are a hell of a lot of stages with the way in which we currently do things. And the way things are starting to move more and more is that it's going to a design print process. So for prototyping, we've really seen that 3D printing is the go-to way of prototyping now. Instead of sourcing out your prototyping, many people are just 3D printing their prototypes in-house, and we've seen that that's a very successful thing to be doing. So also producing end-use parts. So rather than sourcing out manufacture of end-use parts, maybe in a variety of different manufacturing methods, you're able to just 3D print those parts now, so you can ensure that they're accurate enough and strong enough using the right sort of technology like Markforged. And then also for tooling, I mean, I touched on the press tools earlier, but there are many bits of tooling out there that are being used. Many case studies that exist of big names like Siemens, Eaton, Microsoft, really big names using Markforged 3D printers to produce bits of tooling to then use that to create their products. And all of that tooling is in-house. So they have full control over that as well. So if there are any design iterations that need to be made, lead times are not nearly as long as what they used to be. So one interesting thing about 3D printing at the moment is that we're able to 3D print a lot of parts that would be sitting in our stores. So a company that I've been working with recently have actually moved to 3D printing all of their store parts rather than sourcing them in. This has turned out to be a really smart thing to do, as what we found is that about 70% of parts that are bought in and sit on shelves actually don't get used. That's a huge amount of money just sitting on shelves there. So what you can start to do is move to a digital inventory instead of a physical one. And then you can 3D print your parts off as you need them from your 3D printing suite or 3D printer. And this is going to reduce lead times associated with getting those components in. Also give you full control over the design of those parts that would be sitting on your shelves, and then be able to 3D print them as you need them, reducing the amount of overhead costs of storing a huge amount of parts on a shelf, essentially. So another situation that you might be finding yourselves in is that your shelves are looking more like this. So if you're going through a traditional supply chain process, especially in the current climate, you might be experiencing increased lead times on components, possibly things getting lost in the post. Whereas if you're 3D printing your tooling, your store parts, all of these bits that are now possible, especially with Markforged 3D printing, you'll find that you won't end up in this sort of situation, as the only thing that you're really needing is your filaments to run those 3D printers. So we've tried to kind of arm you guys with as much information as possible to help you guys understand what sort of 3D printing solution is going to work best for you. But the best way to really understand if you're getting the right solution for the applications that you're going to need the 3D printer for, or if from this webinar you've seen that maybe you could be using a 3D printer in a way that you didn't think possible beforehand, then the best thing to do is just to get in contact with us. So typically we do something called a walk the line, where we will come in and have a look at your production line, your prototyping shop, your workshop, and we'll point out different areas where 3D printing is really going to work best and give you maximum gains in efficiency in those areas. So what we've switched to recently is doing a virtual walk the line. So we'll do this with photos over the phone, and then we'll work with you providing something called a return on investment document, which I'll cover next. So the return on investment study will be based off looking at some of your parts and the way in which you currently manufacture them, looking at the current costs associated with doing things that way and the current lead times associated with how you're manufacturing currently. And then we'll compare that to the 3D printing alternative, and then we'll be able to tell you if there are savings in 3D printing certain parts, maybe certain jigs and fixtures, end of arm tooling, prototyping, maybe if you're sourcing out your prototyping, then we'll be able to tell you how quickly a 3D printer will pay for itself by doing those jobs over the current method of doing them, and also how much time can be saved by 3D printing those parts over, potentially outsourcing and waiting for those parts to be delivered. So this is all developed in-house by us. All the back end of it is like fully available to you guys if you decide to go through this process with us, so you can see how it all works. And all we would need to do this is some STL files from yourself and some information about your current manufacturing method, and then you can move forward totally risk-free, knowing that a 3D printer is going to be paying for itself within a set time period. So we've got some time now for some questions. So we're going to run through those and start answering those now.
So we've got some great questions in here. So one of the questions we had in was, do we know of any SLA printers that produce UV stable parts? Well, most plastics do inherently degrade in UV. With the Formlabs resins, you can, once they're actually cured with the laser, hardened with the laser, they then actually need to undergo, well, not all of them, but the majority of them need to undergo a curing process. Now, if the resins are actually cured to the recommended time, what that actually does is it actually completes the photopolymerization and actually stables the mechanical properties. So it actually means that those resins are actually going to be, once cured, are actually going to be more stable than the majority of materials.
So I had a good question from Peter, who's asking about, does the strength vary with layer height? So just to cover the different technologies and how they work with producing strength in the Z-axis, where you would be getting the layer buildup. SLA printers produce isotropic parts, so the layers are actually chemically bonded together, so you get really good omnidirectional strength off of SLA prints. FDM prints, because they're laying down molten plastic one layer on top of the other, you will get reduced strength in the Z-axis if you're trying to pull apart a part. So especially with the lower end FDM printers, where maybe they're using a material they're not exactly designed to run, print consistency can vary with those. With the Markforged 3D printers, the layer adhesion is so good that they don't actually absorb any water at all, and the Z-axis strength is far better than other lower end FDM machines. So we actually did some testing with the RNLI on some Markforged 3D printed parts, and we found that the layer adhesion was so good that no water was able to seep in between the layers and reduce the structural integrity. So Markforged parts are actually fit to go out on lifeboats. But yes, you will find that in the Z-axis on an FDM machine, the pull apart strength can be a little bit less. In terms of actually changing the layer resolution to achieve a better strength, say like a 300 micron resolution over or a 50 micron resolution, you won't actually achieve greater layer adhesion by changing the layer height, because it's still going to be the limiting factor is going to be how well those two layers bond together at any point, which would be the failure point.
So we had another good question in here is, would it be correct to assume that SLS processes uses more real world materials? SLS material types are actually generally more limited. So as I mentioned, they tend to be nylon, so nylon 12, nylon 11, and also you can often use TPE as well if you're looking for a more flexible solution. Now, nylon can actually be printed on certain FDM machines if they've got a strong enough and hot enough nozzle. So yes, obviously nylon is a great durable material if you're looking for real world solutions, and the same with the Markforged materials printers as well. Is if you're looking for real world application, the ability to actually reinforce your parts to aluminium strength parts actually lighter than aluminium as well, then again they're really good if you're looking for real world high strength production quality parts. Then Markforged are a good solution with that.
So I have another question from Michael, who's wondering about the costs of SLS 3D printing and also about metal additive manufacturing. So SLS 3D printers are traditionally fairly expensive, to be honest. I mean, they go up from about 120K, and the metal 3D printing solutions, again, very expensive there. I mean, they would start at 150,000 and go up from there. So I'm just looking at the question again. So with the Form Labs, the Fuse 1 would be about £8,000, which is far cheaper than what's currently on the market for SLS 3D printers. But with the post-processing solution with the Fuse 1, it would be around the £12,000, £16,000 mark. Reason my figures are a little bit foggy on the Fuse 1 is that it's coming out towards the end of this year. So we haven't actually got that in-house yet. We're hoping to get our demo unit soon, as it looks like a really great machine, especially as I mentioned that typically SLS 3D printing is very pricey, and Formlabs are doing with SLS what they did with SLA essentially, and really bringing the price down of machines that are currently only available from other companies. I will say that make a good amount of money off of them. So I had another question from Jason, who was wondering about the figures on the ROI study that we showed briefly. So that ROI study was actually done with a company that produces wine, and they were buying in all of their store parts, and they've now actually switched to 3D printing all of their store parts. So I'll just go back to the ROI quickly so you can have a quick look. So they actually needed a 3D printing suite. So they needed a Markforged machine for making some of the tougher components that were previously made out of aluminium. And then they needed some parts that required a really good surface finish, like there were some suction cups. So they started 3D printing those on the Formlabs. And then they had some parts that they wanted to make out of a biocompatible flexible material, which is a very niche material. So we sourced that material and were able to print that on the open source Ultimaker. So a really good range of things that they were looking to achieve there. And we were able to prove out that 3D printing was going to be far cheaper, reduce the lead times that they were experiencing on getting those parts in. And they're able to now iterate on the designs as well to make them really work for them on their production line and carry out production line changeovers far faster. Also being able to make the end of arm tooling on the 3D printers too. So on that 3D printing return on investment, it was a very kind of sure thing because we had some really good figures to go off with to start. But usually an ROI study, the 3D printer will typically pay for itself in about 6 months if it's a Markforged 3D printer on average.
So there's another question with regards to the max temperature, which parts can withstand with SLA technology. Now, there is actually a resin which is specifically designed for high temperature applications. So the high temp resin can actually go up to 289 degrees post-cured. So extremely high temperatures that it's able to withstand. And lastly, with regards to recyclability, that is obviously a massive concern in this day and age. And one of the filaments that we actually use is from a company called Filamentive. And they actually design recycled filaments. So they're a great option. They're really good quality filaments. And they've done all the hard work for you with actually recycling those parts. So definitely one to look into if you do have a 3D printer. An open source 3D printer is to use the Filamentive filaments. If we haven't got round to answering any of your questions, we will contact you directly to answer anything that we've missed on there. Hopefully that has given you a bit of an insight into the various 3D printers out there for the different applications.
And just before we go, I'm going to leave you guys with a quick video on how Markforged 3D printing has been implemented at a company called Lean Machine. I hope you guys enjoyed the presentation, and we'll be answering any questions that we haven't answered now. We're also going to run a quick poll whilst the video is playing, or at the end of the video, depending on if the software will let me do it. But we'll be running a quick poll at the end as well.
One of the big challenges we had with the bending cell was to basically design and integrate everything in a really timely fashion. We were able to actually do it in about 6 months, and that would not have been possible without the additive. We found Markforged by researching for the best printers out there for commercial and industrial quality printing.
One of the parts we make at Lean Machine is an aluminum wire clip like this. The tooling in general, what we used to use was big heavy steel tooling like this to put in our press brake. So one thing we found we could do with printing was actually print these tools instead. The big thing that we saw with Markforged was it took a big step from a hobby printer to something that you can actually make parts out of. And we saw a few sample parts, and then we kind of jumped in with it and haven't looked back. So the first step is that you load the blanks into the trays, which hold 200 parts each. After that, the robot picks the parts out of that tray using an array system and then takes it into the press brake to bend them one at a time. Because of the 3D printing, you have complete control over the profile of your bend. The onyx is actually very good for friction, and it doesn't leave any marring on the part at all. So we have a much nicer part with the printed tooling, and it's easier and cheaper to make the tool, so it's kind of a win-win.
With the continuous fiber, you make a printed part that not only could compete with aluminum parts, but in many cases actually be a better part. So one of the biggest real gains that we found with the 3D printer is that if we want to get parts made, we don't have to go and schedule them out in the machine shop. We don't have to order tools. We don't have to make drawings. We can skip all of that, and we can just get the parts made on the printer. We come in the next day, the parts are ready, we can start testing with them, and we don't have to go and check that they're right. And being able to have every single feature on a printed part coming out within 2 or 3 thou with Z accuracies of less than 1 thou. I mean, the accuracy stuff is huge. It's like, okay, these guys can pretty much do anything.
A quick poll now, and appreciate your answers on the poll. Just going to launch here. So whilst that poll's running, I'll just take you guys through a Markforged case study that I've got towards the end here, which is an interesting one. So this was the first CE-rated lifting tool made on a Markforged 3D printer out of composite carbon fiber reinforced material. So this part was previously made out of steel, and it was lifting pistons that go into a large shipping vessel, which weighed about 1 ton. So instead of producing this part out of steel, where it was far more costly, they've now switched to a Markforged carbon fiber composite jig, which is able to pick up these steel pistons, and it's left them saving a hell of a lot of money where the parts were far more expensive, and also reducing the weight of those parts and the long lead times associated there, and being able to rejig those parts depending on the different size of piston too. But this is a 3D printed lifting tool. As I was explaining earlier, it lifts a piston that weighs about 1 ton. So you can now see what it looks like in action there. And they're able to rejig the design of this in-house. So if they've got different piston sizes and whatnot, they're not having to pay for a whole new design and a new lifting jig to be sourced in, wait weeks for that. They're able to produce another one to match another product very quickly. So an interesting thing that they actually did in the testing phase, if you look to the top right, they've actually got some stress strain sensors on that 3D print. So what they've done in the image is that they've actually just attached them to the top of the print. But an interesting thing that you can do with Markforged 3D printing is you can pause the prints, as we showed with the captive nut earlier. What you can do with the paused print is actually embed sensors inside a print. So you can actually embed a stress strain sensor into a 3D print, and then really get an idea of how it performs and where the stresses are to really help you optimize your designs as well. There's a whole menagerie of ways in which print pausing can be used. With the press tooling that we were talking about earlier, they actually inserted bits of sheet steel into the prints to increase the print strength in very specific areas, as well as the carbon fiber composite reinforcement. So Markforged 3D printers use cloud-based software as well. So you're actually able to 3D print at a remote location. So what Wärtsilä have actually done is they've actually got a 3D printer on one of their shipping vessels, and they can actually do the design work, the slicing, and then send it remotely to the 3D printer on the shipping vessel and 3D print the tools out on the vessel as they need them. So a really interesting way in which the cloud software Eiger that's used with Markforged is actually being utilised to print parts on those shipping vessels. So as I just went through the software, just going to play a quick video that's going to show you guys what Markforged 3D printing software looks like. So this is where your part repository is, where all of your different 3D print jobs would be. So you can filter through all of this relatively easy. And this would be your starting stage where you import your STL file from your CAD software. And then within here, you can see that he's actually selected carbon fiber reinforcement material at the top right there. And now he's going to go into the view where he can actually select exactly where that carbon fiber reinforcement is going to exist. So the best thing to do with a part when you're carbon fiber reinforcing it is have some on the top of the part and some on the bottom usually, to kind of create like an I-beam type arrangement. Usually you won't need carbon fiber through the whole part. So you'd want to strategically select exactly where that fiber is. As I mentioned, all cloud-based, and you can monitor your 3D printers remotely, see what print jobs are queued up on the printer and which ones have been successful or not, and diagnose what sort of prints might be failing. So another thing I touched on earlier was the in-process laser inspection on the Markforged machines. So if you're looking to produce parts to a very fine tolerance and you want to ensure repeatability and reliability and the accuracy of the parts that you're printing, the laser inspection tool really helps you do that. So this is the print head of the Markforged industrial machine, and you can see the laser on there. So within the software, you'd go into your internal view, much like when you're fiber reinforcing, and then you would select certain areas where you want to do a laser scan. So if you've got a bit of geometry on the part where you need to ensure that maybe that hole is meeting tolerance, then you'd want to select that layer to do the laser scan. So just put one laser scan layer in there. And then as the part is printing, it will get to a point where it needs to do that laser scan, and then it will switch to the laser scanner and then scan the part as it's going to do now. So Markforged machines generally work to just over 100 micron tolerance in the XY, but what we've actually found is 3D printing at the top right of the bed, we're able to achieve tolerances of about 25 microns because it's closer to the home position on the 3D printer. But this tool is actually going to give you the tools to check, how far under or over tolerance part is to the pixel, which is going to show you here. So we've put a few different 2D scans, in this part. You can see them populating there. So we're going to have a look at one of those scan layers. So you can see on the graph to the right, we've got blue where it's under 100 microns, and then orange where it's up to 100 microns. We're actually able to mouse over to the pixel to see how far over or under tolerance that very specific bit of geometry is. And then we've got some measuring tools in there as well to measure areas like that internal diameter, which is just put on this as an example there, but didn't quite position that right first time, so we're going to move that circle about a little bit. There's one of the big benefits of 3D scanning a 3D print as it's printing is with 3D printed geometry, complexity never costs you anything extra. So if you, say, decided to 3D print a sphere inside a sphere with traditional inspection equipment, you'd never be able to get the dimensions of that internal sphere. Whereas if you're scanning the part as it's printing, you're able to achieve very accurate inspection results off of very difficult to measure geometry. So, I mean, the reasons why you would go with a Markforged 3D printer is the comprehensive material portfolio. As you mentioned earlier, the materials like the machines and the software is all quality controlled by Markforged to ensure that repeatability and reliability. The strength of the components as well. So there's a chain link there, and it's holding 21,000 pounds, which, if I remember right, is about 1.5 T-Rexes. So it gives you an idea of how much one single chain link can actually hold. Very accessible and easy to use, especially because of the cloud-based software, and an innovation leader on all fronts. That's with materials, producing very strong parts, but also with software, as Markforged are starting to develop something called Blacksmith, which is actually going to increase the accuracy of a 3D printer the longer it's running, as it's going to use that inspection scan data to actually make micro adjustments to the stepper motors in the machine to make the 3D printers more accurate over time over traditional CNC machines that will get less accurate over time. So it's a nice future-proofed solution as well. So I don't know if we've had any more questions pop in. No more questions. So yeah, thank you very much for listening, everybody. And if you do have any more questions about any of the 3D printing technologies that we've covered, or if you would like to have a chat about whether you think an application is possible or not, then do just get in touch and give us a ring, and we'll be happy to discuss that with you. So we work out the same offices as Solid Solutions as well, so you can reach us on that same contact number and just ask for anybody at Solid Print 3D. Okay, thanks for listening, everybody.